This problem, we're going to continue with 7.5 and get your calculator out. I mean, you could just follow along with, but I do want you to know how to use your calculator. And this is definitely going to be a calculator question, because in order to get the correct answer for the area on any of these, really, you need to have the specific y value. And based off of this problem, if they do not give you that, now sometimes what they do is they ask you to set up an equation without solving it. But based off of this problem, I would assume that you would need a calculator for this. Also notice the directions before I get the calculator out, that you need to understand that the line L is tangent at the point 0, 3. So we do know that when we set up this problem, we are going to do the integral, because we're finding the area of region R from some a value. And you can actually call this an a value as long as somewhere in your directions you define a as being equal to some x value, which we're going to figure out, all the way to 0. And based off of this problem, you can actually just write out f of x dx, because sometimes in math it's just easier and it's better it's more legible if you were to define values, so you're not rewriting something over and over again. So as we go to a calculator and we just type into y equals the function, don't forget alpha x is your trick to make the fraction. We're looking at x cubed over 4 and just a friendly reminder to make sure that you are in radian modes, and double check that you type it correctly. So let me double check my mode is correct, because I do change it for other classes. And then I'm going to mess with my window, because I don't care that much about the entire graph. It looks like the x values go from -2 to 4, and then -2 to 4 for both. So just as I type this in, I make sure you hit the negative key. And then -2 to 4 for the y values as well. So as I go to my graph, looks about right. And what I care about is that root right now. So that 0, so second trace. The second option is root. And enter to the left, enter to the right, and about right there. And we get -1.373. So I've defined it. Now everywhere in the problem that I use it, I can do a. And now what I can do is go back to my home screen. And I believe if I want to grab this equation again from my home screen, because it's the last thing I did, if I hit X, enter, it copies down that problem, that value. That only happens if you actually find the root, though. So if I hit, math, the integral of x, I hope this works for me, to 0, alpha trace the equation we had in terms of x. Let me double check that that's the right value. I just don't trust it right now. You don't want to round too early. There we go. So I guess it did the problem correctly. So the area was about 2.903. So we're learning how to use our calculator. In the next one, find the equation of line L. Remember, we need the point and the slope. Well, since we already typed into y1, that should be pretty straightforward because we already have the point. So we know that the equation is going to be y equals some slope, and then x minus the x coordinate, which is 0, so we don't have to write that, plus the y coordinate, which is 3. And that's why it's helpful that we already have it into y1, because now I can hit math, 8 is the derivative d dx of y1 when x equals 0. And I get a slope of negative 0.500 since we're rounding to 3 decimals. Now, if you don't put the 0, 0 there, they do truncate it, so you'd be fine. So now what you would want to do is create that equation on your graph. Negative 0.500x plus 3. So if I go to my graph, you'll actually see it. And now what we need to do, what ordered paired is the other, oh, well, we can use our graph to figure that out. Where's my graph? There it is. Second, trace, point of intersection. It's the 5th option. Move your marker over there as close as possible. Hit enter 3 times. About 3.390. I actually really only care about the x value, but since I asked for the ordered pair, 1.305. So now when I'm finding the area of S, I know that it's going from the integral from 0 to 3.390 of the upper function, which I believe we labeled it as g of x, or we did not. Well, if we don't name it anything, then we have to write out the equation, which wouldn't be that bad. It's negative 0.5x plus 3, and then minus the f of x function, dx. You do want to make sure that you write dx every time you do the integral. I know it probably seems tedious. But now as I go back to my calculator, back to the home screen, I can type in math 9 from 0 to, I already forgot what it was, 3.390. But then I can hit alpha trace y2. Well, let me do this wrong for a second. What if I did y1 minus y2? Because I've saved the equations into my calculator in terms of x. What you'll notice is you'll get a negative area. And so the way to fix that is because area needs to be positive. I should have done y2 minus y1, so it would have been 6.982. Now I'm starting to second guess myself because you shouldn't round too early. So it might be more advantageous if you write all of these numbers 3.3898677. Let me go back. Seeing if I get a better approximation if I make that in terms of x instead. Pretty much the same number, but notice that I get a slightly different answer. So you do need to be careful with that. But anyway, we were correct, and you only have to write down 3 decimals as you do each problem. So what you'll see in the future is you might have a problem that asks you to find the area of one section and an area of another and then add them together. Just to confirm that I have the right answers, you can see he went ahead and changed the decimal to a fraction. Notice he wrote out as many values as he could, and he made a statement that said that you can let b equal some value and then work it out, and you do get the correct answer. So everybody has a little bit of a preference to this. Again, you might be given a task where you need to find the area of different parts. Again, I would go to a calculator, and first thing is just type into my graph, my y equals the correct statements. So we're looking at 1/4 plus, and we're always in radians in calculus, so just double check that you're in radians. And then my second equation, clear that out. We're talking about 4 to the, you do have to hit the negative key, so make sure that you hit the negative key, not the minus key on your calculator. If you look at, we only want the first quadrant. So I don't know exactly where they're going to intersect. So you might just want to play with your window for a little bit. Like, I don't know, hit zoom fit first. Okay, that was a pretty bad graph. So maybe zoom in. But you can see the region that they're talking about right in here. So change your window a little bit to maybe go from negative 0.5 to 1 and hit zoom fit. Zoom 0. Okay, pretty close. Maybe just change that window slightly to go to 1.5. There we go. So now we get a better visual. And if we want to identify the intersection points, we go through the process and find those points of intersection. So that's second trace, the fifth option. Move your cursor over, hit enter. And like I mentioned before, sometimes what we do is we just write out that these values are A, comma, B, and then we try to fit in right there, and we write out the exact value, 0.178218. And maybe even label it over here. 178.218, comma, 0.781. That was a terrible comma. 0.917. And then maybe call this C, comma, D. Second trace, fifth option. Enter thrice. 1.25. And you can change it to a fraction. Nobody's worried that that's 1/4, which should make perfect sense. So if you're finding the area of region R, then it makes perfect sense to say, okay, well, we're going to go from 0 to A. The upper function is the g of x function, and then the lower function would be the f of x function, dx. And so you can go to your calculator and go back to the home screen, math, the ninth option, to go from 0 to A was equal to 0.178. Whoops. .218. Alpha trace, and it doesn't. I mean, it does matter. You want to make sure that you have the upper function written first. I believe it was y2 minus alpha trace y1 in terms of x. And you get 0.065. So as you write the equation for the next one, region S, we're going from A to C. Now, it might not make any sense to write to C here because C is clearly 1. So you have the option to write one or the other. This time the f of x function is higher, the upper function. And I'm running low on time, so I'm going to trust that you can type that in. And then in the last one here, what you'll notice is that if we want the unshaded region, you want to do from 0 to A of, let's see, the curvy one was f of x, the sine curve, f of x dx, because that's the region made. And then you want to add to it the integral from A to 1 of g of x dx. And what you're doing is you're splitting up this area into two pieces. This piece, finding that area's total, and then this piece, area's total. And we need a third piece as well, from 1 until whatever that value is. So let me show you the answer key because I'm running out of time. There you go. You're ready for the homework.